In this lecture, we will go through the embodied energy of materials and the life cycle of buildings, since they deeply influence the sustainability of a construction. The embodied energy of a building material includes all the energy consumed in acquiring and transforming the raw materials into finished products and transporting them to the place of installation or the building site. The energy consumption related to a building realized in Europe with common techniques, assuming a life cycle of 80 years, is derived 80% from its operation and 20% from the embodied energy of the construction materials, including maintenance and renovation. At the end of the operating life, also the energy related to decommissioning has to be taken into account. The life cycle puts into sequence the various stages of materials and identifies where energy is consumed at each stage, from acquisition of raw materials, production and installation, to use and operation, to disposal and ultimate reuse. Considering the embodied energy of different construction materials, it is possible to note that aluminium or plastic have much higher values than of those of wood and concrete. The choice of materials and components becomes increasingly important in energy-conscious design, and this has a great impact on the architectural choices related to the envelope, in particular due to the high embodied energies of glass. In the figure, relative values of embodied energy in some types of facades is shown. The value of a facade with a wood frame is assumed as a 1. RVT is the ratio between the glazed surface and the total surface of the facade. The degree of sustainability of a material or component can be evaluated by means of the life cycle assessment, called LCA. For example, building with the interlocking stabilized soil brick reduces the use of industrial products like cement and depends on local resources. It is considered to be an environmentally friendly technology because it consumes less production energy, reduces deforestation, decreases the use of non-renewable sources and produces less waste from the construction process than the main walling alternatives. Some general recommendations can be listed to reduce embodied energy. Minimize the resource quantity. Make choices that ensure reduction of scrap materials. Select low embodied energy materials and low energy construction systems. Use low energy structural systems like load-bearing walls in place of steel frames. Use naturally available materials, especially organic renewable materials like timber or bamboo. Even non-renewable inorganic materials like stone and clay are useful since they can be reused or recycled. Use durable materials and components. Use materials with more reusable and recyclable potential. Pure material like bricks, wood, concrete, stone and metal sheets are most suitable for this purpose. Composite materials like prefabricated solid foam metal or foam plaster elements are difficult to separate and to recycle. Use industrial waste-based blocks for non-structural or infill wall system. Reuse or recycle construction debris. Use water-based acrylics for paints. Avoid products using asbestos and CFC, and finally minimize the use of metallic surfaces and metallic pipes, fitting and fixtures.